Good morning friends, welcome to Cyber channel. Today we'll see Joules law of heating. So what I did is I have a battery and wires, come ammeter, voltmeter, resistor and a light bulb here. So what I'm going to do is the voltage here is 100. So I'm going to increase gradually. So you can see the brightness of the light bulb is going to be very high, right? So what is happening here is you can see the electron flow as well. So the electron flow is gradually increasing. If I still increase the current, the bulb is going to be illuminated very brightly and more current flows. So what happens here is heat will be generated more. How? Because when I'm increasing the voltage, more current flowing through the resistor as well as bulb. So automatically what will happen is heat will be produced, right? So we'll see by an example, right? So you know what how a fuse works, right? So fuse works on the principle, fuse will have low melting point and high resistivity, right? So now I'm going to set the fuse rating as 20 amps, right? Okay, so when the temperature is going to be very high, so what will happen is the fuse will melt and break the circuit. So we'll see an illustration now. So I'm increasing the voltage gradually. Yes, the brightness is good, the current is 1.7. So you can slowly see I'm going to increase, and you can go in, now the fuse is going to melt. You can see that, yes, it's done. So what happens here is when the current is more, the heat generated will be more. That's what we are going to prove. Okay, as well as resistor as well, right? So now you can see if I'm going to change the resistor value, so the resistor value is 100 ohm. If I'm going to increase the resistor value, you can see the voltage drop across will increase, which will develop as heat. So if I'm increasing the resistance, the voltage drop is more. That is why you can see the light bulb, how it is glowing. The light bulb is, the electrons are going very slowly. You can see that, right? Because more voltage drop is consumed in the resistor itself. So as the heat is more, as the resistance is more heat will be developed. Okay, now we will see. I will give you a homework as well as we are going to derive Joules law of heating. Yeah. Okay, we'll derive first and then you can. So I have connected a conductor. There is a voltage V, current I is flowing in it, right? So you know what is potential difference? Potential difference is nothing but V, which is nothing but work done by charge, right? So what will be W? W is equal to V into Q. So what is Ohm's law? You remember V is equal to IR, right? And what is I? Current is nothing but number of charge flowing per second. So Q is equal to what? IT. So this is what we are going to substitute here. So I'm going to substitute V is equal to IR and Q is equal to ITR. So what will be W? W is equal to IR into IT. So which will give me I square RT. So work done, which is equal to, what is the work done here? Work done is dissipated in the form of heat. So we can say work done has heat as well. So H is equal to I square RT, which is joules, right? So that is the derivation of Joules law, right? Let me summarize. So when I increased the heat, when I increased the voltage, so what happened is the current increased. So when the current increased, what happened? Heat developed will be more, right? And what are the other things? If I increase the resistance, again heat developed will be more. Finally, time. So if you leave, for example, iron box for long duration, definitely it will get heated up very long. So heat depends on square of current, heat depends on resistance, and heat depends on time as well. So you can solve the problems. If you have doubt, you can come back to me. Have a nice evening, and if you like our video, please subscribe and follow us. Thank you.